I'm going to go over the process on how to configure a Raspberry Pi 5 to become a mini router in my house. As you can see, the Raspberry Pi has already been configured to work. I have already downloaded all the updates and the Raspberry Pi is ready to be configured. So what I got here for this setup is I have the modem provided by the ISP, the active Raspberry Pi, and I also have this ZTE CP591 PCIe to 2.5 gigabyte Ethernet port hat for the Raspberry Pi. So how the setup is going to work is I'm going to connect the Raspberry Pi to my ISP modem. This will allow the connection to the internet just like any other device in the house. However, the Raspberry Pi is going to be configured to become a mini router. What I'm also going to do is I'm going to install this ZTE hat on the Raspberry Pi, and then I'm going to configure this card to become the second Ethernet port on the Raspberry Pi. And that secondary port is going to be connected to the switch in my house to enable the physical connection from the switch to the Raspberry Pi, let the Raspberry Pi do all the routing of the internal private IP addresses and convert it into a public IP address that then will be connected to the home modem and let the devices access to the internet. The modem is already doing something like that, but let's say for example, if I connect my computer to the wireless connection in the modem, it's not blocking or filtering anything. It's just allowing everything out, everything in. So the intent is to use this Raspberry Pi 5 to become a router and protect every device in the internal private network. I will be configuring another Raspberry Pi to become a firewall, but to begin with, I'm going to configure this one to become a router. So all the private IP addresses that are connected, that are configured in the switch, and the devices connected to those IP addresses can safely access the internet through the modem provided by the ISP after all the traffic has been filtered through the router. When I set up the Raspberry Pi, I enable SSH to allow me to remotely connect to it from my house computer. All the configuration done in this scenario is going to be done via CLI. So what I'm going to do is I'm going to go back to my computer. I'm going to SSH into the Raspberry Pi 5 and I'm going to start the process. So let me do that right now. Alright, and before I SSH into the Raspberry Pi, I went ahead and install the hat. I want to SSH into the Raspberry Pi and check for the Ethernet port, and then I'll connect the hat and make sure the Raspberry Pi recognizes the secondary Ethernet port. So I have connected the flex cable on the Raspberry Pi, and once I confirm the Raspberry Pi is up, running, and good, I will connect the flex cable to the hat, and then I'll check the connections to make sure I have two Ethernet ports. So I'm going to go ahead and do that right now. I'm going to SSH into the Raspberry Pi. Okay, now I'm going to open terminal, and I'm going to SSH into the mini router. So it's going to be mini router.lan, enter, ask me for the password, and I am in. Okay, now I'm going to clear the screen. And now what I'm going to do is I'm going to check and see how many Ethernet ports I see. And I see one, which is what I would expect. So I only see the Ethernet port in the Raspberry Pi board itself. So what I'm going to do is I'm going to connect the flex cable on the hat. And then I'm going to run this command line again, and the expectation is that I will see another Ethernet port. Okay, and now I'm going to install the flex cable, and you're going to see a little light here if it works. So I'm going to close it. Alright, and now if you see the light is on, So I should be able to see the secondary port from the hat on the Raspberry Pi. So I'm gonna go back to my SSH session and I'm gonna run the command line again. Now I'm going to run the command line again, IP link, and I do not see it yet. So what I'm gonna do is I'm gonna reboot the Raspberry Pi and wait for it to come back and run this command line again. Raspberry Pi rebooted. I'm gonna clear the screen and I'm going to log back into it. Password. Okay. Clear the screen again. Run IP link. And now, as you can see, I have the original Ethernet port, and now I have the Ethernet port from the hat. And now that I have identified the ports for the Raspberry Pi and the Raspberry Pi hat, I'm going to go over the topology for this setup. So I'm going to bring this picture in this text file into focus. And the way it works now is, as you can see, the Raspberry Pi is connected to the ISP modem. And this is getting an IP address of 192.168.40.76, as you can see here. And also, if I look at the computer that I'm working on and check the IP address, I can see that the IP address is a 192.168.40.164. And by that logic, any other device in the home network will have an IP address of a 192.168.40.blah /24 CIDR, which gives us a 255.255.255.0 subnet. And in order for me to set this properly, I'm going to configure the router in a whole new network. I will keep it simple for management, so I will assign the range of the 192.168, and the third octet will be different, it will be 70. And I am going to use a /29 CIDR, which creates a subnet of 255.255.255.248. I had to go with a /29 CIDR block because I need at least 2 IP addresses, and I cannot use a /30 CIDR block because that creates a subnet with only one IP address that can be assigned to a device. I will be hard coding the IP address 192.168.70.1 to the Ethernet port in the hat, which is this one right here. And I will hard code the IP address 192.168.70.2 to the switch in the private network. The built-in Ethernet port in the Raspberry Pi will remain untouched. This will continue to get its IP address from the ISP modem via DHCP. This port right here is just a door from the private network out to the internet. The IP address this is configured on is not important for this setup. How the traffic will flow is, inside the private network, a computer will send a packet to the switch, then the switch will send the same packet to the hat. The hat will masquerade the private IP address. In this case, it would use the IP address assigned to the Ethernet port in the Raspberry Pi. And then the traffic will go out to the ISP modem and from the ISP modem to the internet. The same thing will happen to the traffic coming back from the internet to the computer in the private network. I will add a firewall to the connection between the mini router and the switch, but for right now, this router will serve as the first filter I have in place to net the internal traffic and keep the private network private. Then the switch will handle all the ACLs to block and or allow traffic in and out of the devices connected to the different VLANs in the private network. Okay, and now that we know the topology, let me jump back into the SSH session and start the configuration. Next up, I'm going to enable routing by configuring the persistent forwarding in the Raspberry Pi. Hit enter. And the last part in the process is going to be to configure the NAT in the Raspberry Pi, add the static route to my local VLANs, which will be configured in a switch, and make the configuration permanent. So whenever I have to reboot or lose power on the Raspberry Pi and this restarts, or whatever the case may be, I don't have to go through this process all over again, but it will be saved in SD card. I'm going to go ahead and do that, and then I'll show the routing summary that was created on this meeting. So the router now has been configured. So I'm going to check the routing configuration by running the command line ip-route. And I can see all the IP addresses that I set up. 40.76, which is the default Ethernet port in the Raspberry Pi. The traffic is going to be pushed from the hat to the 192.168.70.2, which is the switch. 192.168.70.1, which is the Raspberry Pi hat, is the source. So yeah, everything seems to be fine. Now the last thing I'm going to check here is the NFT list rule set. Accepted, it's masqueraded on Ethernet 0. Alright, I'm good. Now I want to test it. I'm going to connect the switch to the Raspberry Pi. It's connected to the hat. And I can see the switch coming up. And now let's see if I can ping the router from the switch. The IP address is 192.168.70.1. And yep, it is successful. Now let's see if I can ping Google from the switch. .8. Yep, I have access to the internet. If I look at the IP address of the switch, it's going to be 192.168.70.2, just like we set up in the Raspberry Pi. Okay, so now I know the switch is online, the connection to the Raspberry Pi is enabled. I can ping the Raspberry Pi and I can get online from the switch, which means that the routing is working. However, I'm going to run another test, and now it's from the Raspberry Pi. I'm going to see if I can ping the switch .2, which is the IP address of the switch. Yep, successful. And now let me see if I can ping the default gateway of the computers. So 172.16.14.1. And it knows where it goes to. So the next hop is going to be 70.1, which is my router. So now what I need to do is I need to connect the computer and see if I can get to it. So now I'm logged into this Windows computer and I have plugged the computer to the switch. This will be the 5th computer that is being connected to the switch, so I should be getting an IP address of 172.16.14.5, and that IP address will be issued to the computer by the DHCP scope that I configure locally in the switch. So I'm going to do ipconfig, and sure enough, got a 172.16.14.5. So I am getting a local IP address in a private network. Now the ACL to allow me to go online it's enabled, so I should be able to ping Google, for example. Hit enter, and yes, I can reach Google. So that tells me that I am online. The ACLs in the switch are working, and most importantly, the router that I built with the Raspberry Pi is working. Alright, so this is good. And I'm going to see if I can ping the default gateway for VLAN 14, which is the computer. So ping 172.16.14.1. Success. So now that one computer has received an IP address from the DHCP server, VLAN 14 has come alive, and now the default gateway is active. That's how I can ping it. Even if I try to ping the computer from my current workstation, if I try to ping the computer inside the private network, I'm not able to, because it's protected inside the netting of the router. Even if I try to ping the default gateway, I'm not going to find anything, because for all intents and purposes, that network doesn't exist. Everything is behind the router and behind the ACLs in the switch. So it is private, which is what I wanted. All right, and that is it for this video. that's how you set up your router, and you can see the examples of how that works when you have a private network trying to reach out to the internet, and how you protect your private network from the outside world. Thank you for watching. I will see you in the next one.